Hey, hello, and let's begin. So this is SAT Worksheet 207 functions. Without a doubt, the SAT likes a good function. There are three ways in which the SAT wants you to understand functions. Hence, there are also three sections on this packet. We'll look at all three ways. We'll explain what the test expects you to know, and then we'll work through some problems. So with no further ado, let's get right into it. So first off, what is a function? Well, I'll explain real fast. A function is any type of equation that can be graphed where for every input for x, you only have one output for y. What does that mean? That means that you cannot draw a vertical line anywhere down the xy coordinate plane and hit 2 points on the function. If you do that like this, it's not a function. So in this case, we have two, when x is 7, we have two outputs for y. That's a no-no for a function. What does a function mean? It means for every output for x, there's only one unique output for y. Okay, so anyway, what are the three ways in which we need to understand functions? Well, the three ways in which you need to understand functions, and you'll be tested on them, is you need to understand how to represent a function as an equation, right here. You have to understand how a function can be displayed within a t-chart. And then last but not least, you need to understand how a function can be graphed. So if you think about this one, it's essentially y equals 3x plus 5. We have a gradient or slope of 3, a y-intercept of 5. And the idea is we can input different values for x, and based off of the input that we put in for x, we get a different output for y. For example, if we were to put in -2 for x, we would say f of -2, meaning we put in -2 wherever we see an x. So in this case, right here, plus 5. What does that get us out? That means that if we input -2 for x, we get out 1, right? -6 plus 5 is 1. So the way this reads is if you input -2, your entire output value for when you input -2 is 1. Okay, and that's what the t-chart shows us. And if we go over to our graph right here, this graph got skewed without a doubt. I'm going to have to correct that later. I'm looking right now and I'm saying, wait a minute, when we input -2, oh no, this is wrong. This is wrong right here. When we input -2, we output -1, not 1, -1. That's why it's good to represent functions in all three forms, right? Because hopefully you catch a mistake like I just did. So yeah, if we input -2 times 3 is -6 plus 5, -1. Anyway, I'll move on. I'll move off that point. I know you're probably already bored. All right. So anyway, let's look at just two reads we have to make when we're just given a function in equation form. So one thing is a function inside a function. And if you've seen the movie Inception, you know about a dream inside a dream. Luckily, this is far less confusing than the plot or the concept of Inception. My apologies to Christopher Nolan. Anyway, the way a function inside a function works is you start from the inside and you work your way out. So it's telling us to input 3 into the g function first. So when we input 3 into the g function, we end up getting 3 squared, which is 9. So what does that mean? That means that if we input 3, we output 9. So g of 3 is 9. So essentially, this is now just reading what's f of 9. Well, if you input 9 into the f function, you end up getting, and I'm basing it off of this, the opposite of always input in brackets, 9 squared. Why did I put a negative there? Get rid of that. The opposite of 9 squared plus 8. Well, 9 squared is 81. Opposite of it is -81 plus 8 gives us -73. Okay, so what is f of g of 3? Well, essentially, it's the same as f of 9, and f of 9 is -73. Okay. So that's a function inside a function. Another thing you may get is they may say, hey, we're not going to tell you what the input is. They may say, hey, we told you the input was 3 on this one. On this one, we're not going to tell you what the input is. We'll give you what the output is, and you need to find the input. Well, that's not that bad either. In the case of this problem, they give us a function, and they say, hey, when you input x, you output 0 for y, and essentially what value of x is going to get you 0 for y? So we would say 0 equals x squared minus 8x minus 20. That's an 8, by the way. See if I can do that a little better. There we go. So we get 0 equals x plus 2, x minus 10, right? Because we have to add to negative 8 and multiply to negative 20. And we get, for values of x, we get negative 2 and 10. And on this particular problem, it says x is greater than 0. So that means that x would be 10. So that's just the reverse. They tell you your output 0, what would your input be? And what would that look like? Well, one way that would look like, if we wanted to write it, is that f of 10 would get us an output of 0, right? We put in a t-chart, x, f of x, and we could say, okay, if we input 10, we output 0. Also, we can graph that. Okay. So anyway, let's try, I think I have 1 or 2 picked out from this first section. So let's look at those together. Here we go, number 12. Okay, so I'll give you a moment to read it. If you want to just pause the video and try it, feel free. I'm just gonna keep on going. But anyway, it says we have a function, and if the function g is defined by g of x equals whatever f of x is plus 5, what is g of 3? So the first thing it's telling us is it's saying plug in 3 for x wherever x is. So let's start off with that. F of 3 equals 3 times 3, right? We put in a 3 for both x's, plus 5. That gets us 8 times 3. So f of 3 sorry about that. Sometimes my computer screen goes dark. We will fix this right now. Okay, we're back on. Apologies for that. So anyway, I should probably get a new computer, but anyway, that's beside the point. So f of 3 equals 8 times 3, which is 24. So now that we know f of 3 equals 24, well, they want g of 3. G of 3 is f of 3 plus 5. F of 3 is 24. F of 3 plus 5 is 29. So g of 3 is going to be 29. Notice that c is 24. So that's if you don't go the whole way. On these problems, you always have to be really careful. You always have to double check that you've gone the full length of the problem, that you're answering actually what the question wants. We'll do 14 real fast. So I'll explain it conceptually first. If we put a 3 and a 6 out in front, what does that mean? That means take whatever your output is when you put in x for the r function and multiply all of it by 3. Take whatever your output is for the q function and multiply all of it by 6. So essentially, when we put in x for the r function, we have x squared plus 5x minus 4. Well, if we multiply all that by 3, we end up with 3x squared plus 15x minus 12. And what are we adding to that? I'll put these in brackets. We're adding to that 6 times 2x squared, so that's 12x squared, minus 6 times 3x, so minus 18x, 6 times 4 plus 24. And again, what do? We input x into the q function, and we multiplied that entire output, which was 2x squared minus 3x plus 4. We multiplied that entire output by 6. So all I did was distribute the 6. So anyway, what happens here? So what happens here is we end up with, when we collect like terms, we end up with 15x squared minus 3x plus 12. And luckily for us, that's A. Awesome. All right, so let's go to, do I want to do this one? 20 is a very clever problem, a really clever problem. I'll do it. I think I think it will be helpful to see this one because and if you don't want to see me do it, you can skip on it and maybe come back to it later. But this is definitely a challenging problem. Okay, so it gives us this function, and it says p of x is divisible by x. What is the value of k? So the key thing is to think about what that means. Well, if you think about it, like 5x squared plus 2x would be divisible by x, right? We can factor out an x. So we'd end up with 5x plus 2. 5x squared plus 2, though, is not divisible by x. You can't factor out an x. So in order for it to be divisible by x, we can't have any constants on their own without an x. So how does that play out on this problem? Well, we have 3x squared. This is p of x equals 3x squared plus 30x plus 15. Always be careful to distribute across all terms. And then if we distribute the negative 5, we have negative 5x plus 5k. Very important to know that it becomes a plus 5k. Okay, so essentially, if we're going to divide out an x, well, first let's kind of group our like terms. We have 3x squared plus 25x plus 15 plus 5k. So if we're going to divide out an x, and you can pause here if you think you already know what to do or you want to think about it, but if we're going to divide out an x, that means that this has to disappear, right? This whole part from here to here has to be equal to 0. Then we can divide an x out of what remains over here. So what does that mean? That means k is going to have to be negative 3. Okay. So let's go on to section 2 of 3 sections. And I promise that these other ones will be a little bit shorter. So another big part is they'll present you with the table for a function, and they'll want you to figure out what function actually works with the table. So let's look at this example problem here. The table below gives values for the g function. Which of the following equations could define g? All right, so let me warn you about the number one mistake. The number one mistake is to be lazy on this, to say, oh, okay, so if I input 3, I input 0, I output 3. Let me put this in the first one. I input 0 for x, 6 times 0 is 0, plus 3 is 3. Amazing, it's a, circle it, move on. You think you're great? Well, guess what? No. The way the SAT works, you have to be careful. You have to read every question twice. And if you're given a table on a function, don't just take the first value. If you really think about it, putting in 0 will get you an output of 3 for A, B, and C. In fact, really, and then this is if they really want to be tough on you, but if you put in 3 to the A function, you're going to get 3 times 6, which is 18 plus 3, you get out 21. Well, guess what? If you put in 3 to the C function, 3 squared is 9 times 2 is 18 plus 3, you also get out 21. So it's not until you actually go deep into the table and try a different value that you realize that only C works. If I put in 5 to this first one, I get 6 times 5, that's 30. 30 plus 3 is 33. So this set of values, inputting a 5, does not get you an output of 53. On this one, though, and I'll do it out just so you can see it, if we have g of 5 on answer choice C, we get 2, 5 squared plus 3. 5 squared is 25. 25 times 2 is 50. 50 plus 3 is indeed 53. And if g of 5 is supposed to be 53, well, we did indeed get that here. We got g of 5 equals 50 plus 3. All right, so that's how you want to go about doing these ones. We'll try one out. Okay. This problem's a good one. It's challenging. What I'll do is I'll actually scroll down a tad so you can see the whole problem and try it out if you want to before I talk. All right. But anyway, I'll keep on moving. So if you pause, then you're good. If not, I'm sorry. We always move on. All right. So we have a table, and the table represents function f, and the quadratic function g is defined by this quadratic in standard form. Again, if this looks weird or you don't feel comfortable with this, I really recommend that you visit worksheet 205. That goes over exactly the reads you need to be able to make on polynomials or quadratics. But anyway, the maximum value of g of x is how many units greater than the maximum value of f of x. Well, if you look at the table for f of x, the highest value is 4, and we can feel pretty comfortable that that's the highest value because look here, it tells us it's a quadratic, which is a parabola. If you put in 1, you get an output of 4. And if you look, if you put in 0, you get 3. We'll call that 3. And if you put in 2, you also get 3. So immediately we see that we're kind of coming down from this parabola here. Okay, so we know the maximum value of the f of x function is 4, and they want to know how much greater is the g of x function. So this, again, you really kind of want to know your concepts from worksheet 205, parabolas, but the way you get the maximum value of this one is x equals negative b over 2a will get you the x value of the vertex. So what we have is negative 2 over 2 times negative 1 for a. So really we end up with 1, negative 2 over 2. You put that back in to get the output value, which will be the maximum value. It will give you the vertex. And if you think about it, if you put in 1, what we end up with is, and brackets is crucial because we square the 1, we get 1, but then we apply negative to it, so that's negative 1 plus 2 plus 15. So we end up with 16. So we know that for this one right here, the parabola is going to look something like this. That when we input 1, we're going to output, and I should probably have drawn this up higher so it's not really proportional, but we should output 16, and then it opens down because we have a negative in the a spot. So anyway, the maximum of the g of x function is 16. The maximum of the f of x function is 4. 16 minus 4 gets us 12. Be careful of D and be careful of A. Why? Because they're just trick answers. What they did is they essentially gave you the individual maximums of the f function and the g function, but what they didn't do is they didn't give you the difference between the two. And always double read the question, because it's always about not what answering your own question, but what the question actually wants, which is how many units greater is the maximum of the g function from the f one. Okay, last concept, and this is probably the most advanced. So sometimes what we get is we get graphs, and we have to be able to read graphs. And sometimes we get these polynomial functions that seem intimidating, especially if you haven't done A-level math or further math. Well, don't fret. There's a couple ways to do this. That won't be too bad. Where am I moving myself? I don't even know if this is moving on your screen. But anyway, just trying to get myself out of the way. So what we have is we have which of the following equations could represent what's being graphed here. So there are 4 things you can do to get this. The first thing, the easiest thing to do, is to check your x-intercepts. So if we check our x-intercepts, we know that we're crossing at, it's hard to see, but at -1 and at +3. In other words, we know that we're crossing at a higher positive value than we are at a negative value with their distance from 0. So what does that mean? That actually gets rid of b immediately. Because b is saying that your x-intercepts are going to be at -3 and 1. Well, what would that look like? You'd have to shift where you'd be crossing at like 1 here and -3 over here, right? So immediately looking at our x-intercepts, we know the answer isn't b. So what other reads can we make on this? Because all these other ones have the same x-intercepts. Well, another read you can make is you can check the degree of your polynomial, meaning that if you multiplied everything out, what would be the highest indice or power of x? This one, if we multiply everything out, if you think about it, it's x minus 3, x minus 3, x minus 1, x minus 1. If you were to multiply everything out, the highest indice you'd get would be x to the 4th. You'd have a bunch of things following it, but you'd eventually have x times x times x times x. X to the 4th would be out front. And the big thing with the polynomials is that if you have an even number as your highest exponent or indice, then your end behavior, meaning what direction you go to as x goes towards infinity and x goes towards negative infinity, your end behavior has to be the same. If you think about it, just think about what x squared is. X squared looks like this. Why does it look like that? It's an even exponent, so your end behaviors both go in the same direction. Whereas x to the third, what would that look like? Well, that looks like that, right, in black, where your end behaviors are opposites. And if you think about it, it makes sense. X squared, if I put in a negative number for x, I square it and it turns positive. So if I were to put in -5, I'd output 25. If I put in 5, I'd output 25. So that's why the end behaviors are the same, because everything turns towards a positive direction. Where x to the third, because it's an odd exponent, if I input 5, I output 125. If I input -5, I output -125. So -5 times -5 times -5 is going to end up being a negative. So odd exponents will, if that's your highest degree, they go in the opposite direction. So what does that all mean for this? That means essentially that the answer choice, not only is it not B due to the X-intercepts, but it's also not D. Because if you look, our end behavior is opposite. As we go towards infinity on this one, we go towards a negative. As we go towards negative infinity, we go towards positive infinity for y. So now we're down to A and C. And the easy read to make is, if you think about it, x to the third, you'd be going towards positive infinity as your x gets greater and greater and greater. But on this one, we're going towards negative infinity. Why is that? Because we have a negative out front. That negative out front takes all these positive values and flips them negative, right? If you were to think about x to the negative third, right? If we had negative x to the third, what does that do? Well, that takes every single output we get and it flips it like that, right? So anyway, that's kind of all the official reads to make, and you can read more about it here. But there's actually a secret way to get this that's really, really, really easy. And you can always do it whenever you're in doubt. You can, if nothing else, and you're not sure what to do, you can just plug points from the graph. So we already kind of made the intercept read, so that got rid of B. We made the degree polynomial read. So let's just say we're down to A and C. Well, here's what we know. We know that if we're going to input, this looks like, so from here to here is 10. So that's 2, 4, 6, 8, 10. All right. So it looks like this point, let's go off of an intercept. It looks like if we input 2 right here, right? This is 2. If we input 2, it looks like we're going to output roughly 20. So if we take this point to 20, negative 220, I apologize. If we put that into the C function, -2 minus 3 squared, we end up getting -5 squared, which is 25, -2 plus 1. That's going to get us -1. -1 times 25 is going to be -25. Well, look, we'd be all the way somewhere down here, right? Like beyond what I can show you on my screen. So that's clearly not even coming close to matching the point that we see directly on the graph. If we play that same game and plug in the point -2, expecting roughly about 20 out, well, if you think about it, we'll get -2 minus 3 squared again, -2 plus 1. This is going to be -1 again. This is going to be -5 squared, which is 25. But if you remember, this negative's out front. So really, we get -25, but then it turns to 25. So putting in -2, we get out 25. That's pretty close to the point we had here. I probably could have done a better job of eyeing that up. But anyway, that's another way you can kind of figure out any one of these problems where you have the function and you want to know what function matches the graph. We will try one out, and then that will be it for the video. So let's see which one we want to try out. I think actually it's this one. So let's do this one. It's very similar to the one we just did. I'm going to zoom out just a tad so we can see everything. Feel free to pause it if you want to try to do it yourself. Otherwise, I'm just going to quickly explain. So first thing is we can get rid of, right off the bat, by checking our x-intercepts, we can get rid of A and we can get rid of D. Why? Well, actually, if you think about it, if we put in 0 for x, we're supposed to get out -3 or 3, according to these two. So you can always check your intercepts with your x-intercepts and your y-intercept. In fact, this is both our x-intercept and our y-intercept at the same time. But yeah, if you plug in 0 for x, looking at the y-intercept, you're supposed to get out 0. You don't for A and D, right? You get out -3 and 3. So then we're down to B and C. So the question becomes, how do we know which one? Well, the easy way is, if you remember x to the third, our n behaviors are opposites when we go to an odd power. And the implication is that as we go more and more positive, we take to the third, we output a higher and higher positive. But if we put a negative in front of it, this would flip. So because we're trending negative as we put in positive for x, we need this negative out front. What you could do, though, again, really easy to do, if you're not certain, if you're down to either B or C, is just pick a point. Really, that easy. So if we want to just pick a point, we know that if we input 2, we should be outputting about 6. So watch what happens if I try this on B. If I have 2 to the third minus 2 times 2 squared minus 3 times 2. What we get is we get 8 minus 8 minus 6. So this is saying, hey, if you were to input 2 according to B, if you were to input 2, I'll say f of 2, it's saying you'd output -6. Well, this is saying, no, what's up here is f of 2 equals 6. Well, if you were to put it in for C, and I encourage you to do it, the only difference is we have that negative out front. So that's eventually going to turn this -6 into a +6. If you go through the steps, you'll see that. So anyway, you can make the reads or you can plug points. Good luck with the rest of the problems on this packet. And as always, plenty more videos for any of these worksheets.